Most people think their gut is just a long tube that processes food. That's the part they teach in school. It's technically accurate and almost entirely useless as far as your actual health is concerned. The real action happens in the last 5 feet of your digestive tract. Down in your large intestine, there are somewhere between 38 and 100 trillion individual bacteria. Each one is consuming, fermenting, producing chemicals that reach your brain, your joints, your immune system. I used to work in nursing, and I watched patients cycle through the same prescriptions: acid blockers, repeated antibiotic courses, fiber powders, over and over for the same problems. None of those things fed the microbiome. They managed symptoms. They didn't rebuild the soil, so to speak. Prebiotics do, and not the expensive powder kind either. The kind that have been growing in gardens and along roadsides for centuries. I grow most of what I eat on a homestead here in rural Oregon. And today, I'm going to walk you through 15 plants that feed your gut bacteria the way no pill has ever managed. Stay with me, because plant number 11 is one that most people actively pull out of their gardens and throw away. And it may be the single most important prebiotic food in the Northern Hemisphere. If you've ever grown these in a raised bed, you know they spread like they've got plans of their own. Jerusalem artichokes, I call them sunchokes, are not artichokes, and they're not from Jerusalem. They're native to North America, and they are, gram for gram, one of the richest food sources of inulin you'll find in any garden. Inulin is a type of fructan fiber. Your digestive system cannot break it down, and that's the entire point. It passes through your small intestine completely intact, arrives in your large intestine, and becomes essentially an all-you-can-eat buffet for bifidobacterium and lactobacillus species. Think of it like changing the fertilizer in a garden. You don't eliminate the weeds by hand. You give the useful plants such a head start that the weeds can't compete. Research confirms that inulin content in fresh sunchoke tubers ranges from around 10 to 19 grams per 100 grams, and that number shifts depending on when you harvest and how you store them. The fresher, the higher the inulin. Studies suggest regular inulin consumption measurably shifts the ratio of beneficial to harmful bacteria within 4 weeks. For comparison, a commercial inulin supplement capsule typically delivers 2 to 4 grams per serving. One portion of raw sunchoke gives you several times that amount. The math alone is worth paying attention to. Here's my method. I scrub the tubers cold, don't peel them. The skin holds additional fiber. I slice them thin, about the thickness of a coin. I eat them raw in small amounts, maybe 60 grams to start. And I want to be direct with you here. If you jump to a full portion on day 1, you will regret it. Inulin ferments rapidly. The gas is significant. I'm not exaggerating. I work my gut up to it over 2 weeks. By week 3, most people notice less bloating overall, not more, because the beneficial bacteria have started producing short-chain fatty acids that calm the gut lining. It's a process, not a quick fix. Chicory is the plant the commercial food industry quietly relies on when it needs to add dietary fiber to a label without changing the flavor. You've seen it on the back of protein bars. The chicory root extract they're using is inulin-type fructan, pulled from the same plant that grows as a sky blue weed along roadsides across the entire Northern Hemisphere. The fresh root contains roughly 11 to 20 grams of inulin per 100 grams, and by dry weight, researchers have measured inulin concentrations anywhere from 41 to 68%, depending on variety and season. That concentration is exactly why it became the commercial extraction source of choice. Evidence indicates that chicory-derived inulin promotes measurable increases in bifidobacterium populations, with corresponding reductions in markers for intestinal inflammation. There's a second story in chicory root that most people miss entirely. It contains sesquiterpene lactones, the compounds responsible for its characteristic bitterness. Those bitter molecules stimulate bile production. More bile means your body breaks down dietary fat more efficiently and your liver cycles more cleanly. That's not a minor footnote. Your liver is involved in more metabolic processes than most people realize. Chicory is doing 2 separate jobs simultaneously. I keep dried chicory root in a jar on my kitchen shelf year-round. My morning preparation is simple. 1 teaspoon of dried root simmered in 2 cups of water for 12 minutes, then strained and drunk warm before breakfast. That's it. It tastes like coffee with a note of dark caramel and something earthy underneath. It doesn't need sweetener. If you really want some, use a small amount of raw honey. Honey carries its own prebiotic oligosaccharides, something I'll return to at the end of this video. I want to address something directly. When people hear garlic is good for you, they think of allicin, the antimicrobial compound that forms when you crush a clove. That's real, and it matters, but it's not the prebiotic story, and the prebiotic story is arguably more important for long-term gut health. Raw garlic contains fructans, a class of prebiotic fiber, at roughly 3 to 6% of fresh weight by most measurements, with total fructan concentrations in some studies approaching 9%. These fibers selectively feed bifidobacterium and lactobacillus. The word selectively is the key term here. They're not a general fuel source for everything in your gut. They preferentially grow specific populations that produce specific beneficial compounds. Preliminary research also suggests garlic's fructans may help suppress the growth of certain pathogenic bacteria, without flattening the overall microbial ecosystem the way a broad antibiotic does. One study published in Frontiers in Nutrition described it as showing better prebiotic properties than commercial fructooligosaccharides extracts for some lactobacillus strains. That's a significant finding that hasn't made it into mainstream conversation at all. Raw is the priority. Cooking degrades fructan content significantly. Heat breaks the chains down into simple sugars, which your body just absorbs before they reach the bacteria that need them. I crush 1 or 2 raw cloves, let them rest 10 minutes. That's when allicin also fully forms. Then add them to whatever I'm eating. Good olive oil helps cut the heat. If raw garlic is genuinely too intense for your gut initially, and for some people it is, especially early on, fermented black garlic retains a reasonable portion of its prebiotic content and is noticeably gentler. The fermentation process transforms the sulfur compounds and the sugars, so you're getting a different but still meaningful fiber profile. Leeks don't get nearly the attention they deserve. They sit quietly in the garden, growing slowly through autumn and winter, and most people treat them as a mild onion substitute. They're so much more than that. Like garlic, leeks are allium family, and they carry a similar fructooligosaccharides profile, but in a form that many people with more sensitive digestive systems tolerate considerably better. Here's something that most cooks don't know. The prebiotic fiber concentrates in the green tops. The dark green leaves contain significantly higher levels of prebiotic compounds than the pale white shaft that most recipes call for. For years, I was throwing away the best part of the plant. I'd encourage you to reconsider what you do with those dark green tops. Leeks also contain camphorol, a flavonoid that cell studies suggest may help support the integrity of the gut lining itself. Think of your gut lining like the walls of your greenhouse. The bacteria inside are your plants. You can have perfect soil and perfect plants, but if the walls have gaps, the weather gets in and ruins everything. Keeping that lining intact is not a secondary concern. It's the whole project. I use the entire leek, dark green tops included. I give them a thorough wash since soil collects in the layers. Then I slice thin and cook gently in a small amount of butter and water, not oil alone, which can get too hot and stress the fiber. Light heat is the phrase to keep in mind. Leek prebiotic fiber is more heat-stable than garlic's, but prolonged high heat still converts much of the fructooligosaccharides into simple sugars. Soft, translucent leeks are correct. Browned, caramelized leeks are delicious. I love them, but by that point you've given up most of the prebiotic benefit. Asparagus is one of the few plants on this list that most people already consider a health food, but almost nobody knows why it belongs specifically in a prebiotic conversation. The reason has nothing to do with its vitamin content. It has everything to do with the fiber inside the stems. Asparagus contains inulin-type fructans, the same structural family as Jerusalem artichoke and chicory. In a raw spear, roughly 2 to 3 grams of prebiotic fiber per 100 grams. It's a lower concentration than sunchokes, but asparagus is generally easier on the gut because the fiber comes packaged with saponins, which appear to have a soothing effect on the intestinal lining and may ease the fermentation process for sensitive systems. Asparagus also contains asparagine, an amino acid that can serve as a nitrogen source for certain gut bacteria. So you're not just feeding the bacteria carbohydrates, you're providing some of the raw materials they need to grow. Evidence for asparagus as a prebiotic food is supported by both traditional use across European and Middle Eastern cultures and more recent in vitro biochemical studies of the fiber composition. Raw asparagus in thin strips is my preference. I use a vegetable peeler to create long ribbons, dress them with lemon juice and a small amount of good olive oil, and eat them just like that. That's the highest prebiotic preparation. If you're cooking asparagus, steam it only, and pull it while it still has some resistance. The moment it goes fully limp, you've cooked past the window where the fiber is doing its best work. I eat asparagus several times a week from April through June. That's peak season here in Oregon. The rest of the year, I rely on the other plants in this list. Seasonality matters more than people realize. Your gut bacteria actually shift in composition across the seasons, and eating with the season supports that natural rhythm rather than fighting it. Here's the plant I mentioned in the beginning, the one people pull out and throw away, dandelion. And I want to be clear that I'm not talking about a root powder supplement. I'm talking about the plant growing in your garden right now. The whole plant, root, crown, and leaf, contains a prebiotic fiber profile that competes with chicory root in terms of concentration. Dandelion root is documented to contain up to around 40% inulin by dry weight, a figure that multiple medical and phytochemical sources now confirm. By fresh weight, accounting for the root's high water content, that works out to roughly 4 to 12% depending on season and harvest time. Autumn harvested roots are consistently the highest. The leaves are a different kind of prebiotic story. They contain bitter sesquiterpene lactones, specifically taraxacin and taraxaccharin, that trigger bile secretion, stimulate gastric juice production, and effectively prime the entire digestive cascade before food even arrives. This is a plant that prepares the gut to function, not just feeds it. Evidence is well documented across European, Chinese, and North American traditional medicine systems, and the inulin content has been chemically confirmed in laboratory analysis. Now here's the counterintuitive part I promised. Young dandelion leaves, pulled before the plant flowers, have a fiber-to-calorie ratio that is exceptional. They're not a garnish. They're one of the most nutritionally dense prebiotic foods available, and they're currently growing free in most of your gardens, being treated as a problem. When multiple unconnected traditional cultures across centuries independently keep the same plant in their practice, that overlap is worth taking seriously. Young dandelion leaves, wash thoroughly, eat raw in small amounts. They're slightly bitter, which is actually a good sign. That bitterness reflects the bile-stimulating compounds doing exactly what they're supposed to do. I add them to other greens so the flavor integrates rather than dominates. A small handful goes a long way. Dandelion root tea is my winter prebiotic. I dig roots in autumn, scrub them, slice thin, and dry them on a rack in my kitchen. I simmer 1 tablespoon of dried root in 2 cups of water for 15 minutes, then strain and drink it, warm. It's earthy, slightly sweet, nothing like the bitterness of the leaves. One hard rule: if your garden uses any pesticides or herbicides, don't eat dandelions from it. Go further out, the edge of a field, a meadow you know hasn't been treated. I have a spot about a quarter mile down the road where I've been picking for years. Know your source. That applies to every forage plant in this video. Onion is in the allium family alongside garlic and leek, and it carries a fructooligosacharide profile that overlaps with both, but the specific chain lengths in onion tend to be shorter, which means they ferment faster and provide a more immediate fuel source for certain bacterial populations. Different chain lengths feed different bacterial species. It's worth thinking of these plants as a complementary toolkit rather than interchangeable options. Raw onion delivers the highest prebiotic load. Studies suggest cooking can reduce fructooligosacharide content substantially, in some preparations by around 50%. And here's something most people don't know. The outer 2 or 3 layers of an onion, the ones closest to the papery skin, contain notably higher quercetin concentrations than the inner layers. Quercetin is a flavonoid with documented anti-inflammatory properties. Most people peel those layers off without a second thought. Red and yellow onions outperform white in prebiotic content. The colored varieties contain more of the flavonoids that appear to work alongside the prebiotic fiber, supporting the gut environment while the bacteria do their work. White onions are still useful. They're just not the best tool for this particular job. I slice a quarter of a raw red onion thin and add it to whatever I'm having for lunch. That's the whole preparation. No soaking required. The sharpness that people try to remove is partly the prebiotic sulfur compounds doing exactly what they should. Removing it defeats the purpose. If raw onion does bother your gut at first, pickle thin sliced red onion in raw apple cider vinegar for about an hour. The short fermentation softens the sulfur profile while preserving a good portion of the prebiotic fiber, and the vinegar contributes to a slightly lower gut pH, which most beneficial bacteria prefer anyway. When we talk about oats as a prebiotic, we're not talking about the instant sachet version with the little fruit pieces. We're talking about the fiber structure that survives in oat groats and traditional rolled oats, specifically a compound called beta-glucan, which behaves very differently from the inulin-type fructans we've covered so far. Beta-glucan forms a thick, viscous gel in your digestive tract. That gel does 2 things simultaneously. It slows sugar absorption, helpful for anyone managing blood sugar, and it creates a physical structure that certain gut bacteria colonize and feed on. Research published in Springer's Current Nutrition Reports found that consuming 80 grams of whole grain oats per day significantly increased Akkermansia mucinifera populations in study participants. That's a meaningful finding. Akkermansia mucinifera lives in and feeds on the mucus layer that protects the intestinal wall. Without adequate prebiotic support, Akkermansia populations decline, and that mucus layer begins to thin. The medical term for what happens next is increased intestinal permeability. The plain English is, things that shouldn't get through start getting through. It's associated with a wide range of inflammatory conditions, and it's preventable with the right diet. Soaking oat groats overnight is the step most people skip. 12 hours in cold water softens the groat, begins a mild fermentation process, and increases the bioavailability of the beta-glucan. I drain and rinse in the morning, then cook in fresh water for about 25 minutes. Cold oats, fully cooked, then refrigerated overnight, contain a higher proportion of resistant starch than warm oats. Resistant starch functions similarly to a prebiotic. It resists digestion in the upper gut and arrives in the large intestine to feed bacteria. If you're making oats, make a large batch, refrigerate it, and eat it cold or gently rewarmed, not piping hot. Flaxseed's reputation has largely been built around its omega-3 content, specifically alpha-linolenic acid, and its lignans. Both of those are real and worth your attention. But the prebiotic story sits in a third component, the seed coat, which contains a mucilaginous fiber that forms a gel even more pronounced than oat beta-glucan. That mucilage functions as a prebiotic substrate. It feeds specific bacterial populations, and in doing so, may help support the structural integrity of the gut lining. Evidence indicates a preferential stimulation of lactobacillus and bifidobacterium populations with regular consumption of whole ground flaxseed. The ground version is important because whole seeds often pass through intact, particularly if your digestive system isn't producing optimal secretions to break them down. The lignans in flaxseed are also chemically transformed by gut bacteria into compounds called enterolignans, specifically enterodiol and enterolactone. This is a case where the microbiome is doing active chemical work for your body. You're not just feeding bacteria. The bacteria are producing compounds that your body then uses. It's a more complex relationship than most people imagine. I grind my own flaxseed fresh, about a week's supply at a time, in a small spice grinder. I keep the ground meal in an airtight container in the refrigerator. The oils in ground flaxseed oxidize quickly at room temperature, which degrades both the omega-3 content and the fiber structure. Pre-ground flaxseed sold in bags at room temperature has likely already lost a significant portion of its value. 1 tablespoon daily is a reasonable starting amount. I stir it into water and drink it before it gels. That takes about 5 minutes. Or I fold it into oatmeal or soup. Letting it sit in liquid for a few minutes before eating actually improves the prebiotic effect because the gel needs to form before it does its job in the gut. Burdock root is the plant that Velcro was invented to imitate. The seed heads that stick to dog fur were the original inspiration. The root is something entirely different. In Japan, it's called gobo and eaten as a vegetable. In European herbalism, it's a long-standing liver and digestive tonic. In a prebiotic context, it's a plant worth knowing. Burdock root is a meaningful source of inulin-type fructans. A 2020 review published in Food Research International confirmed the root contains prebiotic fructans alongside chlorogenic acid, quercetin, and other phenolic compounds with documented antioxidant activity. The exact fresh weight inulin figures vary considerably by study and extraction method, from around 3.5 to 7 grams per 100 grams fresh root, which is a solid prebiotic contribution for a root vegetable eaten in relatively generous portions. The traditional use of burdock as a liver tonic and blood-supporting plant appears across European, Chinese, and Native American medicine with notable consistency. When multiple unconnected traditions arrive at the same plant for the same complaint across centuries, that overlap is worth respecting, even before the biochemistry catches up to explain it. Evidence here is based on well-recorded ethnopharmacological use, and the phenolic compound profile has been confirmed analytically. I prepare burdock the way I learned from Japanese cooking. Julienne strips, soaked briefly in cold water to reduce the slight earthiness, then stir-fried in sesame oil with a small amount of soy sauce. It holds its texture beautifully and has a mild, earthy sweetness underneath. It's also excellent in miso soup, where the base broth adds its own fermentation compounds. The combination of burdock fiber with fermented miso, which contains live bacterial cultures, creates a layered prebiotic and probiotic effect in one bowl. Simple and genuinely effective. Not the banana, the weed. Broadleaf plantain and narrow-leaf plantain are 2 of the most common lawn weeds in the temperate world. They grow in driveways, between pavers, along the edges of fields. Every mowed lawn in Oregon has them, and they contain mucilaginous fiber, the same gel-forming compound used in commercial psyllium husk supplements, at no cost whatsoever. Plantain leaf contains polysaccharides that form a thick gel in the digestive tract, coating the gut lining as they pass. This is one of the most well-documented mechanisms in the traditional use of this plant. The European Medicines Agency published a formal herbal monograph on Plantago lanceolata, specifically recognizing its traditional use for soothing mucous membranes, which includes the intestinal lining. The gel-forming behavior is chemically confirmed. The gel acts as a lubricant and a prebiotic substrate simultaneously. It feeds bacteria while physically protecting the mucosal layer beneath. In acute gut irritation, the kind that shows up as urgency, cramping, loose stools, plantain leaf tea has been a first response intervention across multiple traditional systems for a very long time. Not a cure, a tool that buys the gut time to stabilize. Young plantain leaves, pulled before the plant sends up a seed spike, are tender enough to use raw in small amounts as a salad addition. Slightly bitter, slightly mineral. Once the seed spike appears, the leaves toughen considerably and are better used for tea or dried for later. For tea, 2 tablespoons of fresh leaf or 1 tablespoon of dried, steeped in near boiling water for 10 minutes with the cup or pot covered. Covering matters. The volatile, aromatic compounds that contribute to the plant's anti-inflammatory activity will evaporate from an open cup. Steep covered. Drink warm. Wild garlic, called ramps in North America, ramson in Britain, is a different species from cultivated garlic but from the same Allium genus. It carpet grows in deciduous woodland in early spring. Here in Oregon, I know exactly which patch of Douglas fir forest to visit in April. You smell it before you see it. Unmistakably garlic. Wild garlic shares the fructooligosacharide profile of its cultivated cousin, but presents a noticeably more complex sulfur compound array. The leaves, flowers, and small bulbs are all edible and all bioactive. Preliminary research suggests that the leaf extract may have a broader antimicrobial profile than cultivated garlic bulb. Though standardized human clinical trials are limited, most of the evidence to date comes from laboratory and in vitro studies. The harvest window is narrow, 8 to 10 weeks in spring, before the canopy closes and shades the plant out. I gather leaves before the flowers fully open. That's the peak period for leaf nutrient density. Once it flowers, the plant redirects its energy towards seed production, and the leaf profile shifts. I use wild garlic leaves raw wherever I'd use fresh basil, in a rough pesto, tossed with pasta, folded through scrambled eggs, or simply torn into a spring salad. The flavor is gentler than cultivated garlic with a clean green note underneath. It's genuinely one of the best things that comes out of my local forest each year. Important safety note: wild garlic grows in the same environments as lily of the valley, which is toxic. The distinguishing factor is straightforward: smell. Crush a leaf between your fingers. Wild garlic smells unmistakably of garlic. Lily of the valley has no garlic scent whatsoever. Smell before you eat every single time. Don't skip this step. Stinging nettle has one of the most complete nutritional profiles of any wild plant in the Northern Hemisphere. Iron, calcium, magnesium, vitamins A, C, and K, meaningful protein, in concentrations that rival or exceed many cultivated vegetables. The sting is a deterrent, not a barrier. Once blanched or dried, the stinging mechanism is completely deactivated. From a prebiotic standpoint, nettle contains polysaccharides that preliminary observations suggest may act as prebiotic substrates, feeding beneficial bacteria, while simultaneously exerting some anti-inflammatory influence on the gut lining. The two effects appear to work simultaneously, nourishing the beneficial bacteria while dampening the inflammatory signals that harmful bacteria tend to exploit. More human clinical research is needed, but the traditional use evidence and the biochemical plausibility are both strong. Nettle also contains a lectin called urtica-dioica agglutinin, a compound that has shown interesting interactions with immune receptors in gut cell studies. The clinical picture in humans is still developing. What is well established? Nettle has been used as a spring nutritive tonic across European traditions for centuries, and its mineral density alone justifies incorporating it into a regular diet. I harvest young nettle tops in spring, the top 6 inches of the plant, before it flowers. Thick gloves, always. Blanch in boiling water for 60 seconds, which deactivates the sting completely. Then drain and use exactly like spinach. Nettle soup is a traditional dish across Ireland and Scotland, and it's genuinely good. Hearty, mineral, earthy. Nettle tea, dried leaves steeped for 15 minutes, is my daily mineral supplement. 1 cup provides a meaningful amount of calcium and magnesium in a bioavailable form. I've replaced most of my calcium supplements with nettle tea plus a small amount of dairy, and my blood work has stayed consistent over the years. I'm not saying that's the right path for everyone, but it's been right for me. The phrase, "an apple a day," has been dismissed as folk wisdom so long that people stopped asking whether it might be pointing at something real. Part of the answer, at least, is pectin. Apple pectin is a soluble fiber that acts as a prebiotic, specifically feeding Faecalibacterium prausnitzii, one of the most clinically significant bacteria in current gut health research. Research published in Applied and Environmental Microbiology confirmed that most Faecalibacterium prausnitzii strains grow well on apple pectin and ferment it primarily into butyrate, the short-chain fatty acid that serves as the primary fuel source for the cells lining your colon. Without adequate butyrate, those colonocytes begin to deteriorate. F. prausnitzii is also consistently found in lower concentrations in people with inflammatory bowel conditions, which makes supporting its population a meaningful target. The majority of pectin sits in the skin and the layer just beneath it. A peeled apple provides fiber but significantly less prebiotic pectin. This is one of those cases where the most convenient thing to remove, the skin, is the most biologically valuable part. Heirloom apple varieties from farmers' markets or older orchards tend to have higher pectin concentrations than commercial varieties bred for uniform appearance and extended shelf life. Eat the whole apple, skin on. That's the single preparation instruction for this module. If pesticide residue is a concern, and it's a reasonable one for commercially grown apples, buy organic or grow your own. I have 2 heirloom trees on my property that produce more than I can use each autumn. I dry the excess in thin slices for the rest of the year. Unsweetened applesauce, cooked lightly and left chunky enough to retain some fiber texture, preserves a good portion of the pectin. Interestingly, the pectin in cooked apple may be slightly more accessible to gut bacteria than in raw apple, as heat partially breaks down the cell walls that otherwise contain it. The key word is unsweetened. Added sugar actively suppresses the beneficial bacteria you're trying to build. I saved this one for last deliberately. Honey is sugar, that's what everyone knows, and for commercially processed heat-pasteurized honey, that characterization is largely accurate. Raw honey, unheated, unfiltered, is biochemically something different, and the difference matters in a gut health context. Raw honey contains oligosaccharides, including glucoligosaccharides and fructooligosaccharides, that have demonstrated prebiotic activity in vitro and animal studies. A 2022 review in Frontiers in Nutrition summarized multiple lines of evidence showing that honey supports growth of bifidobacterium and lactobacillus species, while simultaneously inhibiting several pathogenic strains. It's doing 2 jobs at once. Whether those effects translate reliably to the same magnitude in healthy humans across diverse honey types is still being investigated, but the mechanistic basis is real and well characterized. Raw honey also contains an enzyme system, glucose oxidase, that generates low-level hydrogen peroxide, contributing to its well-documented antimicrobial properties. This is not the same as swallowing a disinfectant. The concentrations are mild and highly selective. The antimicrobial research on honey is extensive and predates the antibiotic era. The prebiotic research is newer and builds on that same foundation. The prebiotic oligosaccharides in raw honey make up only a small fraction of its total composition, somewhere between 1 and 11% by weight depending on floral source and processing, with most raw honeys sitting in the lower portion of that range. So you're not eating honey for bulk fiber. You're using a small amount as a precise addition to a broader prebiotic strategy. That's a meaningful distinction. 1 teaspoon of raw honey in a glass of room temperature water, 30 minutes before a meal. That's the traditional preparation used across multiple cultures over centuries, and it's how I use it. Room temperature water matters. Heat above roughly 40 degrees Celsius begins to degrade the enzyme systems and the more delicate oligosaccharide structures. Don't stir it into hot tea and expect the same effect. One final thing I want to say clearly. Honey is still a sugar. If you're managing blood sugar carefully, the prebiotic benefit does not override that conversation. Have it with your doctor or your dietitian. The appropriate amount here is small, 1 teaspoon. This is not a food to eat freely under the banner of gut health. It's one precise tool in a broader strategy. I want you to use this information well. 15 plants, most of them growing within 100 feet of wherever you're standing right now. I've been working with these plants in my garden and my kitchen for over a decade, and I've watched the emerging gut microbiome research slowly catch up to what traditional herbalists and observant gardeners knew intuitively. that you can feed your gut bacteria with the same care and attention you'd give a vegetable garden. The pharmaceutical model for gut health is symptom management. The prebiotic model is ecosystem building. Those are not the same project, and they don't produce the same results over time. I'm not telling you to stop listening to your gastroenterologist. I'm telling you to bring these plants into that conversation. If this video added something useful to your day, please subscribe. I publish a new video every week on the same premise, that the garden, the hedgerow, and the kitchen shelf are still our most reliable allies. There's a great deal more to cover, and I'm not going anywhere. Before you go, I have a genuine question for you. Of the 15 plants we covered today, which one do you think is the most underestimated in terms of what research is still uncovering about its mechanism? Leave your answer in the comments and tell me why you chose it.